All right, to start this week, we have a really cool section that's really neat. But if your logarithm skills are rusty, this week will be harder for you, okay? So it really builds on all of chapter 4 and really kind of builds on chapter 3 as well. And it leads us to a really cool result. The third video is going to be fun. But this first video, we're just going to review, okay? So this is just a review video, hopefully nothing new from your college algebra course or high school or wherever you may be coming from. If you want other resources to review logarithms, don't hesitate to contact me and I can give you all the work that you need. So let's review some properties of logarithms. If I have the log of two things multiplied by each other, we can split that up as two separate logarithms connected by addition. So multiplication on the inside is addition on the outside of logarithms. And very similarly, division on the inside will be subtraction on the outside. So these are properties that hopefully you have seen before. Hopefully this is not completely new. And last property that we're really using is that if I have an exponent in the middle, that's going to be multiplication on the outside. Okay, so we're going to be utilizing these three properties all today with all of this section. So this video is just kind of using them a little bit and reviewing a little stuff, and then we get into some calculus in the next video. So example 1, write as a single logarithm, or the book sometimes will say simplify. I think which form is simpler is a little up for debate, but simplify is really one of the most nebulous words, I think, but math, we always use it, and I don't think it's as clearly defined as people might want it to be. But we'll have to save that for my ranting video about math. Anyway, here we go. Right as a single logarithm. So there's a couple things going on right here, right? We have a logarithm plus a logarithm. Logarithm plus a logarithm means multiplication on the inside. But we also have this 2 out in front. We need to deal with that first. Because notice in our property, this property doesn't have anything in front, right? This property doesn't work if there's something out in front. So we're going to have to use property number 3 to get rid of that 2 in front. Multiplication on the outside is an exponent on the inside. All right, so we have to get rid of this 2 first. And again, using that property, this 2 comes in here. This is going to be the natural log of 5 plus the natural log of 3 squared. And 3 squared is a really nice number because we know exactly what that is. We can simplify that. 3 squared is just 9. And now, once we have a single logarithm plus another single logarithm with no funny business going on, we can use that first property. Okay? That adding logarithms is the same as multiplying their insides. So what we have here is this becomes the natural log of their product, which is 45. And that's our answer. And again, if you plugged in this left thing into your calculator and you plugged in this right thing into your calculator, you should get the same decimal approximation. It's a good way to check your answer. All right. That's basically this first video. Let's get some more practice in. Let's look at 1/2 times the natural log of 4t minus the natural log of t squared plus 1. A couple things at play here. Remember, just like last time, we're first going to have to deal with this pesky little 1/2 in front. And then this thing is already in the right form. Has no funny business. Just, it's got a bit of a mess on the inside, but that's not a big deal. Let's deal with that 1/2. That 1/2, according to our property, goes to an exponent. This becomes the natural log of 4t to the 1/2 power minus the natural log of t squared plus 1. And, oh, I didn't notice that my tablet just ended. That was the edge. We fell off the world. All right, so let's subtract the natural log, t squared plus 1, like so. Okay, starting writing on my desk. Excuse me. All right, so be very careful here. When you move this into the exponent, these parentheses are really important. All right, so don't forget those. It's not just 4t to the 1/2 without parentheses. Not the same thing. And remember, a 1/2 is a square root. So we have a lot going on right now. One thing at a time. The square root of 4t. Well, the square root of 4 is just 2. And the square root of t, we don't know. So again, that's looking at this. Square root of 4, that's 2. Square root of t, we don't know. So we'll write square root of t minus the natural log of t squared plus 1 again. And now it's our final step. We have a natural log subtracting another natural log. That's division of the inside. So it'll be the natural log of 2 root t over t squared plus 1. That's as simple as it gets. Beautiful. And again, it really is up for debate which form is nicer. But this is what the book wants you to do. All right. And it's good practice. We'll show why it's good practice in future videos. Let's do example 2. Another refresher course. Solve for x. So we're going to have to use properties of logarithms here to do these solving ones. Natural log of the square root of x minus 2 natural log of 3. And there's a couple of ways of going about this. All right. Let's rewrite things a little bit. The natural log of the square root of x. I don't like square roots. But remember, the square root of x is x to the 1/2. So we can actually write this as 1/2 times the natural log of x. And vice versa with this one. This 2 can go in front. Or inside, 3 squared is 9. Because we want the x by itself. Okay? So let's add, excuse me, let's add the natural log of 9 to both sides. That'll give us 1/2 times the natural log of x equals the natural log of 9, and we're almost done. We want the x by itself, multiply both sides by 2. Be very careful with this right-hand side. This is not the natural log of 18. If you thought it was a natural log of 18, hold yourself back. Maybe write it as the natural log of 9 with parentheses. The 2 does not go inside the natural log. We're going to get the natural log of x equals 2 times the natural log of 9. To put the 2 inside, again, it has to go into the exponent. We'll get the natural log of x equals the natural log of 9 squared, which is 81. That's how the 2 gets inside. Natural log is a 1-1 function, so this will only ever be true when their insides are the same, okay? This means that x has to be 81. All right? There's a lot of ways of solving these problems. I did a very long way, but I think it's a way that makes sense and has step-by-step stuff that makes sense. Get the x by itself. All right? Is usually what we want. This doesn't work for every equation, but for a lot of equations, getting x by itself is a good way to go. And we could check our answer, right? If we plug in 81 here, what does this become? The natural log of the square root of 81, the natural log of 9. This is also the natural log of 9. Yeah, natural log of 9 minus the natural log of 9 is 0, sure. Do one more. Part B. The natural log of x minus 3 times x plus 2 minus the natural log of x plus 2. Goodness, why did I choose this problem? Squared, maybe? A little messy in my notes. Minus the natural log of 7 equals 0. Sometimes things are not so nice. So let's get everything with an x on the left, everything without an x on the right. So what we're going to do is our first step is we are actually going to combine these. A natural log minus another natural log is division. This gives us the natural log of x minus 3 times x plus 2 over x plus 2 squared. And then we still have that minus natural log of 7. Let's move that over to the right-hand side. And just like last time, if I have a natural log equal to another natural log, their insides must be the same. But even better, look at this. We have an x plus 2 up here, an x plus 2 over here. Those cancel. So when we set their insides equal to each other, it's actually something very nice. X minus 3 over x plus 2 has to equal 7. We can cross multiply, write it as 7 over 1. And distribute. That'll give us 7x plus 14 equals x minus 3. Rearrange some stuff and we'll get 6x should equal negative 17, maybe. Ooh, this is a weird number. I wonder if I made a mistake. Negative 17 over 6. Potentially. Yeah, I'm real nervous about this one. I may have written down the problem down wrong. Let's check our answer with the calculator, okay? So let's go to Desmos. Let's learn together. Yeah, I agree, Desmos. And see what we got. All right, wait. I can't do it over here because what was our answer? Negative 17 over 6. Let's check. Is the natural log of negative 17 over 6 negative 17 over 6 minus 3 times negative 17 over 6 plus 2. That natural log minus the natural log, negative 17 over 6 plus 2 squared minus the natural log of 7. Woo-hoo! All right, I was nervous there, but look at it. That equals 0. That's exactly what we wanted. All right, so we did it. Congrats to us. Checked our answer. This is our beautiful final answer. And that's the first video. Hope you enjoyed it. We'll move on to differentiating and logarithmic differentiation in the next two.